Welcome, ladies and gentlemen, to this video lecture. Okay, so now we come to two very important theorems. So this is what is called the remainder theorem and the factor theorem. So let us talk about the remainder theorem. So if you have a polynomial fx, so let fx be a polynomial over C, and let gx be a degree 1 polynomial over C. So we've got fx is a polynomial over C and gx is a degree 1 polynomial over C. Then there is an easy way to work out the remainder of the division of fx by gx. The remainder of division of fx by gx equals the value of f at C, where what is the C? The C is this constant, or let's say minus the constant term in our polynomial g. And notice here we've got a minus C there and we've got a plus C there. So that is not a mistake. That is indeed correct. So the remainder is given by just evaluating the polynomial at C. Okay, so let's actually prove this. Proof. So by the division algorithm, there exist unique polynomials. There exist unique polynomials, the quotient qx and rx with fx equal to equal to qx times gx plus rx, and now importantly, and the degree of the remainder is strictly less than the degree of the divisor, so the degree of gx. But what is the degree of gx? That is exactly 1. And the degree of a polynomial is always greater or equal to 0. So the degree of r is greater or equal to 0, but is strictly less than 1. That means the degree of r is equal to 0. So if the degree of r is equal to 0, that means that it is a constant polynomial. So therefore rx is a constant polynomial. Meaning there exists some constant number, let's call it p. There exists some p so that rx is equal to p. Okay, so now let us show that f of C is actually equal to this p. So f of C, what is that? So remember we had, so what are we going to do? We are going to take Q of C times G of C plus R of C. But here we've got Q of C. What is G? G is X minus C, but now we're substituting the C in there, so we get C minus C plus RC, but it doesn't matter what X is, this is always equal to P. This is equal to 0, so we've got 0 plus P, and this is equal to P. And now if we note that P is equal to Rx, we have that f of C is equal to the remainder of the division. And there we are done. Okay, so do note here, this only works for polynomials of degree 1 as divisors. So if we are dividing by a polynomial of degree 1, it is easy to determine what the remainder by the of the division is just by substituting in the minus the constant term into whatever we are dividing. Again, this only works for degree 1 polynomials. Okay, and there is an easy consequence of this. So, and this is what is called the factor theorem. So let me start on a new page, theorem. And this is what is called the factor theorem. So when is one polynomial a factor of another polynomial is if you can factor out that polynomial. Or stated in a different way, if the division of the one polynomial by the other polynomial is has remainder 0. So a polynomial, gx defined as x minus c is a factor of a polynomial fx if and only if f of c is equal to 0. So we can easily see when a degree 1 polynomial is a factor of another polynomial when we substitute in, or we apply the polynomial that we are dividing to minus the constant term of this degree 1 polynomial, and we get 0. So this gives us an easy check of when a degree 1 polynomial is a factor of any other polynomial. We just need to substitute in. And in the next couple of videos, we will see some examples. I will see you in the next ones.